We've talked about the center of when we're looking at discrete random variables, but now let's talk about spread. In other words, the variance in this case. Example 7.1, we're going to look at more bets. Suppose that I offer you a choice of three bets. A, you win a buck or you lose a buck with the same probability. B, you either win $5 or lose $5 with, once again, equal probability, 0.5. And C, you win $5 with probability of 0.8, so that's looking pretty good, but you lose $20 with probability 0.2. So, interesting. It says determine the expected value of each bet and also interpret what the expected values mean. I'm going to do two of them, and I'm going to do A and I'm going to do C, and I want you to do B on your own. But let's start with A. So remember, to get the expected value, what I'm going to do is I'm going to get my pen working first, take the value that I'm going to win, multiply it by that probability, and then in this case, what I'm going to lose times that probability. And if I add those together, you get 0, which makes sense. Now, if I was to draw a little graph of it, I'd have something like this. My center is at 0. Probability is 0.5 for each of these, either losing a buck or getting a buck. Now, the range in this case, remember that's the high value minus the low value, is going to be 2. 1 minus a -1 gives me 2. Please pause the video and do the same thing for B, and then come back and check your answer. Hopefully you took a moment and you said, okay, did the same thing, drew the chart. Now remember, range is a measure of that spread of the data. Is it the best one? Well, no, remember, it's really affected by outliers. So hopefully you saw in the expected value of B is the same, but the range is different because there's more spread of the data. In other words, we're further away from the center, which is 0. The final one, let's see, we're going to win $5 with probability of 0.8. That's looking more promising. But on the other hand, we can lose $20 with a probability of 0.2. The expected value of this one's also 0. But this little chart's going to look a little bit different. So we've got minus 20 out here, and these are obviously not all to scale. Probability of 0.2. But then way over here somewhere is 5. Win $5. Probability of 0.8. Now here, the range is 25. So how would I interpret this, looking at these three bets? In the long run, we expect to break even with any of the bets on average if you place these bets over and over again. So once again, we've got that in the long run. We also are looking at on average, and we talk about that in context. Now, what's the primary difference between these three options? Looking at them, thinking about what we remember about a quantitative variable, the centers are all the same, but the spreads are definitely different, and the shapes are different. A and B are both symmetric, but C is skewed, and it's skewed which way? We'll hopefully think the weirdness is to the left, but they all have the same mean. Remember, when we're looking at quantitative data, we need to look at those four aspects being the typical value, in other words, center, variability, or your spread of your data, the shape, excuse me, and any unusual observations. So let's talk about range here. While it is telling, it may not tell the whole story. Range, we've looked at, like I said earlier, it's very, very, very sensitive to outliers. Another measure of variance is standard deviation. But to get to standard deviation, we need to calculate variance. So let's walk through the steps. The variance of a random variable is a measure of how far the outcomes are likely to be from the expected value. So I'm going to do EV as the expected value, and the measurements of the V being value that we're looking at. So take the possible value and subtract the expected value. So we're going to do this step by step. So that's the first step. Now we're going to square that difference. You're like, well, why would you have to square it? This way, they're all positives and they won't cancel each other out, those differences. Now you're going to multiply that. We're going to weight it effectively by the probability, and then we're going to do that for all the values. And this is your variance. Now the square root of that gives us the standard deviation. It's roughly the average amount that outcome values deviate from the expected value. Calculate the variance of standard deviation for each bet. Let's do bet C first. This is the one where students tend to struggle the most. The variance for C. What are the values that we have for bet C? So if you go back up, we see that for bet C, we have two values. We've got losing 20 bucks or making $5. And then we have the related probabilities. Okay. And the expected value for that was 0. So we're going to take that minus 20. So we're taking one of the values, subtracting the expected value, which is 0, squaring it, and multiplying by the probability of that happening. We're also going to do the same thing with the 5 and multiply that by the 0.8, and you end up with 100. So that's the variance. But remember, standard deviation is the square root of the variance. So we get the square root of 100 here, and that is 10. Now you should do the same steps for A and B, and I'll give you the check figures. If you have any problems, please come to office hours to get some help. So hopefully, please take a moment and check your answer. Now, which bet has the smallest standard deviation and which has the largest? And explain why you could have anticipated this. Well, let's take a look. A is obviously the smallest. It's got the smallest value. And C has the largest value. And that makes sense because if we go back up here, if we're looking, remember, we're thinking about spread. Here, the values -1 and +1 are very close to 0, where here the center is 0, but we've got this -20 way out there. Remember, we want to measure the spread of the data. So A has the smallest and C has the largest. C is spread out and dramatic looking, and whereas in A, the values are close to the mean. Now looking at bet D, you win $2 with probability 0.5, and you lose $0 with probability 0.5. Now, obviously, this doesn't make a lot of sense because you're like, well, wait a minute, did you bet anything? But don't worry about that part. What I want you to, one more time, what I want us to think about instead is how does this look compared to a different bet? So in bet D is you can either lose no money, probability 0.5, or you can make $2, probability 0.5. The expected value of that one is going to be 1 again, or excuse me, not again, it's going to be 1, and the variance is going to be 1, and the standard deviation will be 1. And you should take a moment to calculate these and make sure you get them. So how do bets A and D differ? If we look at them, just to remind ourselves, bet A look like this. They look very similar, don't they? The range here is 2 for each of them. The standard deviation is 1 for each of them, but the expected values are different. So all that's happening with D is it shifted right up by $1. So D is A shifted up by $1. The expected value changes, but the standard deviations and variance do not. And why does that make sense? Well, because remember, we're not really changing, we're changing where this is, but we're not changing any of the probabilities. We're not changing how far away they are from center. So it makes sense that the expected value and would change because it's obviously got shifted, but that this spread here did not change. So what does this tell us? Adding a constant does not change variance or standard deviation. It just adds the same constant to the expected value. So without calculation, when you did that roulette example, which bet has the larger variance, number or color? Now we should be able to do this without a calculator. Remember, we want the larger variance. Well, is there a lot of variability in the color? Well, no. You've got mostly black and red, and then you have a couple of green, just two green. But the numbers vary from 1 up, and they go up to 36. So there we can see that the number is going to be what would vary the most. And if you look at the wheel, you'd see that would make sense because there's half of them are red, well, almost half are red, almost half are green, whereas each number is only has one slot on the wheel.